All right. Good morning, everyone. Let's get this figured out here. All right. I'm going to need some help from you guys. You have to let me know whether my mic and my camera are working. This is the first time that we're trying kind of more of a live stream. Welcome to Promess. I'm down here in Promess's war room. We're going to be doing a little bit of a software demo today. Kind of showing you guys a little bit of the inside workings of the Promess software and getting a good idea of kind of the meat and potatoes of Promess applications. Say an estimate would be like 70% of our applications in the world are probably moved to Signal, which is mainly moving to a particular force. Thank you everyone for responding to that. Just to get started, some quick housekeeping stuff. Hey, Jason. Hi, Holly. We're going to have a Q&A towards the end of the presentation. But since we're kind of doing a live stream, I'm going to be looking at the chat. So if you guys have or if you have any questions during the presentation, feel free to ask them while we're going. To get started, where's everyone from? Go ahead and post in the chat just to make sure your chat's working. Where are you guys from? I know we have some guys in here from Europe and Asia, also Canada. I know there's a couple Canadians on there at least. See some of my West Coast guys there too. Kalamazoo, Oregon. Nice. Lots of Mexico. Nice. Well, I do appreciate you guys jumping on today. Good to see everyone. Hopefully everyone's happy, healthy, safe. We'll go into a little bit of the press mechanics real quick, just to show you guys what we're working with. So for the most part, looking at the list of attendees, most of you know really what Promess does, what our presses do. But just to give those who don't know, who may be new to Promess, some of the basic information about the press. So here we have a simple Promess press cylinder. The mechanics are pretty simple. It's a ball screw driven ram. Ball screws housed inside of the cylinder. The silver band you see up at the top is the load cell that's integrated into the system. Behind, driven through a belt and pulley system, is the servo motor. The servo motor houses the encoder, which gives us our position. And then the load cell obviously gives us our closed loop feedback on the load. So what we're going to do today, for the most part, is set up a move to Signal. So I'll show you guys a little bit of the software. So this is kind of a test program that we set up earlier. This is kind of what we're going to be creating today. We have a couple springs, a green one and a red one. I hope to pass, make the green one a good part and the red one a bad part. But essentially, we're gonna set up a program from scratch. So this program is already set up. In the software, you can see that I have a live force readout over here, a live position readout right here. We're going to create a monitoring window today, and we'll also create some gauging data. For those of you that are probably more familiar with our Motion Pro software, which is kind of the single axis solution, this software that you're looking at is actually our Ultra Pro software, which is kind of the latest and greatest from Promess. It has multi-axis capability. This is obviously just a single axis system, so we won't be going over any multi-axis stuff, but a lot of the same programming principles will still apply. for the Motion Pro guys that are out there, you'll see some quality of life improvements that we've made in the Ultra Pro, specifically allowing you to edit while programs are running. And then once a press comes out of cycle, you can actually save those settings to a controller, which really allows some flexibility. As the Motion Pro guys know that, you have to open up the edit program screen in the Motion Pro, make your changes, click save, wait for it to download to the card. With Ultra Pro, it's a little bit different. It's kind of always editing in the background, and then you just have to basically wait for the controller to be ready, and then you can save whatever changes you made. So I'm going to start with basically a brand new program here. And what you guys are looking at is basically what you start with a brand new program. We have a main column over here and a press column over here. The only difference between the two is the main column is going to do all of your evaluation, all of your program flow stuff, your decision making, and the press column is only for movement of that press axis. If this was a multi-axis system, you would see multiple columns in here. So this would say like press axis 1, press axis 2, press axis 3, and all of those axes would just be motion axes, and then you have all of your main programming in here. Something that's a little bit new to this, it kind of works almost like an Excel sheet. So I have a button up here that I can insert rows. So I can begin to insert, just blank rows. I can delete those rows. Pretty simple user interface. Instead of just inserting steps, which you can also do, you can just add blank rows and then just plop in where you need to add your different programming steps. So what we want to do first is basically, I'm going to show you guys how we typically find, say, the top of a part. We'll use the jog function for that. I'm going to kind of do this in an iterative process. So we'll set up the initial rapid positioning, and then we'll set up the monitoring, and then we'll set up the gauging. So I'll kind of show you guys in larger steps what we're doing. And like I mentioned earlier, for anybody that's joined on since the intro, if you guys do have any questions during it, please feel free to pop them in there. Not seeing any questions right now. Hey, Danny. Hey, Mr. Cornish. Good to see you in here. So yeah, what we're going to do, basically, first step is we need to find the top of the press. So actually, let's load. I'm going to save this to the controller. So test webinar is now my program. I'm going to load this program in the HMI, so I'm not using someone else's program here. So the first thing that we need to do is we're going to jog down to the top of the spring here. So most of you probably already are familiar with our jog screen: live, position, and force, jog, extend, and retract, all updates live. We do have an incremental position, which most of you know. So if I wanted to say move to 17.3, I can put in, say, 10 millimeters in here, do an incremental extend. That's going to move to 17.3 millimeters. Obviously, I have a jog speed and overload in there too. Let's switch over to the press camera. I'm going to jog down to, oops. So let me set a low overload in there. Oops. There we go. Sorry, I'm still learning how to use this. So we're going to jog just to above the spring here. So 62.9, we'll call that. Just above the spring. We'll go into our programming here. So much easier way to edit steps versus say our older software, the Motion Pro. All I have to do is say insert a move step here and basically tell it, you know, I want to move to 62.9. Oop. Should use the right 62.9. Basically tell it how far you want to go, how fast you want to get there. One thing you'll notice in the programming is versus the older Motion Pro software is it'll actually tell you if there's a program error live. So you'll see here that, you know, the setting exceeds the maximum allowed speed of 120 millimeters per second. It highlights this step here. It highlights the actual step in the software, and it'll also give you an error up here. One of the nice things is you won't be able to load this program. So say you make all these changes to the program, you download it to the controller. In Motion Pro, it would allow you to run that program as long as you weren't having an error. And then if you did have that error, it would actually fault out the system and require you to say rehome it or reset the machine. Here we actually tell you before any of that happens. So we'll set an overload limit 100. I have to remember to not use those numbers. So we're going to move down to 62.9 and we'll move at 100 millimeters per second. And then we're going to have to move back up, right? So nice thing in the software, I can click and hit Control C and then Control V, and we'll move that back up to 0 at the same speed. So if I save that to the controller and then I switch this over, now that I've done manual motion, I do have to home it. And we'll do a cycle start. So basically down and up. So we've gone from essentially powering up the system to a new program to moving the press all within, you know, the first 10 minutes here. As long as the press has power to it and you can connect to the software, full control over the press. You don't have to mess with any ladder logic. You don't have to tell the motor specifically how many counts to move. You just basically tell it, you know, how far you want to go, how fast you want to get there. Set an overload limit just in case you run into some tooling or something like that. And then you're essentially ready to go. What we need to do now is add some monitoring in. So basically, most of our applications, I'm not going to go into like anything super detailed with our advanced applications, but in most monitoring, we do a force over distance. So you'll see on the y-axis, we'll have force, the x-axis will have distance, and we'll create that right now. Jason asked a question, why start on row 2? No reason. This is it's sequential programming, but it doesn't recognize empty rows as errors or empty steps. So I just do it to kind of space things out for my own eyeballs. You could theoretically get rid of all these extra steps in here and run the same exact program. And it does the exact same thing. So I do it more for just spacing out my stuff. In Motion Pro, typically I do that with like comments. So you can add like a comment and put like a couple stars, and that would kind of add some spacing in there. It just makes it a little bit easier on the eyes and allows me to insert stuff in the middle. The overload limit from Jorge is intended to detect a possible undesired collision. Yeah, essentially that is he's talking about this overload limit here in the step. So we have two types of overloads. One is a step overload limit and one is a system overload. For this particular system, it's a 3 kilonewton. So the the maximum overload that you can have on this system is 3 kilonewtons or 3,000 newtons. But the step overloads allow you to have a little bit more flexibility with running into things. So say I set a part in there that was a little bit too tall. I might want to recognize that part before I actually proceed on to pressing to the move to signal or moving to a force. It allows for detecting, say, if the operator put in the tooling upside down or put the part in the wrong way. There's some ways that you can use that to kind of to quality check while you're doing your process. Good question, though. Thanks. Let's see. So we're going to add a monitoring step. Monitoring is in this second tab over here. We're going to create a new monitor. We'll just call it force V position and click OK. So everything that happens in a monitor step always happens under this acquire. So this acquire means that we're now going to collect position as the actual position as the X value, and the Y value is going to be our force reading. We do have some different sampling rates. So if you're doing, say, certain tests over a long period of time, you can dial down the sampling rate just so you're not collecting so much data. And we'll save that to the controller. We'll go back over here. So basically, I want to wrap it down to a position, start my monitoring, and then move to signal or move to a force, which is what we're going to do. And then we want to stop the monitoring and then move back up. So what I'm going to do in here is I'm going to add I have to add it to my main because it has to do with evaluation. So either evaluation or program flow is what's going to happen in the main. What we want to add in here is what's called a monitor trigger. So as you can see, this resource is already populated in there because that's the only monitor that I have. And I want to start that monitor. And then I'm also going to put in a stop monitor just before the movement back up. So I'm going to put in a stop and analyze. A normal stop action will just pause the data collection and you can restart it. Say you have a certain operator action or something like that that has to happen in the middle. You can use stop, but if you're planning on analyzing right then and there, you can drop that in. And you'll see also I can't put a main step on the same line as a movement step. So it helps you to kind of keep it sequential. Basically says it's disabled the cell because there's something else in here. With movement steps across multiple axes, you can also you can put movement steps on the same. And we even have a motion queuing with multiple axes where we can either queue that motion with the next step or wait for that motion step to complete before continuing on with the program. It's helpful in some multi-axis things. So basically what we've put in here, let's just put in a comment. So rapid position, another comment, start monitoring. This allows you to kind of segment your programs a little bit. It really helps with the longer programs that you have. Okay, and then we'll save that to the controller. We'll go over to our HMI. You see that there's a graph here now. If I cycle start this, we're not actually going to touch anything, so we're not going to get really any graph here. So what I'm going to do is now add in my move to signal step here. So we open it up. We have to select a control input, which we're going to use the force reading from the sensor. You can use live variables. You can use hard-coded variables depending on what you're doing in your program. You can set those programmatically. It's really customizable, but we'll just go off of the basic force reading. from the sensor. We'll set a target value to say 500 newtons. We'll set that speed to 10. Make sure I have all my ducks in a row here. On the move to signal, there's a couple steps that we have to pay attention to in here. So one is the maximum travel limit. So basically what, oh, hold on. Pressing numbers again. Sorry about that. I don't know how much of that you guys just saw, but I'll go through this again. So we've set the target value to 500 newtons, the speed to 10 millimeters per second. There's some settings down here. Maximum travel limit, I'm going to put 100 in there. Basically, that's just the maximum distance that the press will travel while looking for that force. So if you don't reach, say, 500 newtons before 100 millimeters, the press will actually stop trying to find that force and go on to the next step in the program, which is generally going to be a step that looks for, okay, did we reach our force? Yes or no? Okay, if we didn't, then fail the part or notify the operator. And then the overload limit, basically what we talked about earlier. We'll just put 1500 in there again. So we're going to wrap it down to 62.9. We're going to start our data acquisition or our monitor acquisition. We're going to have a move to signal, which is going to a target force value of 500 newtons at 10 millimeters per second. And then we'll stop and analyze that monitor after this. So we'll go back to the HMI. The press is ready, so we're going to hit cycle start again. And there we go. So now we've acquired that force over distance curve. We didn't have to write any special code or anything to be able to pull that data, to mess with those sensors. We didn't have to do any ladder logic to be dependent on, you know, where the press was or anything like that. Very basic. Mr. Jeffrey Cornish asked, what does the acceleration or deceleration do? Good question. Acceleration and deceleration is essentially how fast the press will ramp up or ramp down to its intended speed. So in 99.9% of the cases, you're always going to want that at the maximum, which is usually 1,000 millimeters per second squared. That is pretty standard. The only time that we really mess with that is when we have, like, say, torque applications with high inertial loads where we have to maybe speed up heavy tooling quicker, or not quicker, but slower, because we don't want to overload the torque system. Sometimes we do it with heavy tooling on presses as well to be able to react to the heavier loads that the presses are seeing during those fast movements or those fast travels. Good question, though. Thank you. So now we have our move to signal in there. We have a monitor. Basically, what we want to do now is tell this press here that this green spring is good and the red spring is bad. So if we come back to the software, I'm going to go back into the monitoring tab. I'm going to click show graph up here at the top. And it says a reference curve has not been set. So what that means is basically, for you Motion Pro guys, this is us teaching what that good part is. So if I select a reference curve, it's going to pull up a dialog that allows me to select that last part that I ran. There's obviously parts, or there's cycles without any data in them, but we want the one with it. So I'm going to select it here and click set as reference curve. Now this is essentially my top part. I'm telling the press system to use this as an example. So now we can kind of dive into making it pass or fail. So we have this little toolbox up here. We call this system our DABX toolbox and our DABX strategy. DABX, D-A-B-E-X, means data analysis by example. So essentially, we're telling the controller what a good part is based off of historical data that we know is a good part or a bad part, and creating that system around what we know to be a good part. So I'm going to open up this toolbox, and we're basically, let's just say we want to look from 66 millimeters to 71 millimeters as a window of what we want to consider good for the part. So first we want to create a window. I'll double click it there. And I said 66. Let's do this. 66 to, what did I say, 71? Okay. So as you can see, live in real time, 66 to 71 is now my monitoring window. If you guys are familiar with, say, our relative limits, let's set a relative upper limit and a relative lower limit inside of that window. And I've only just clicked, but basically that's set the relative offsets at a default of 50 newtons. But now this part, if it looks anything other than this and breaks outside of these limits, it will actually fail the part. So if I click Save to Controller, I go over to my HMI and I run a cycle start. Now you see that I've set that that pass-fail limits. Now, if I was to, sorry about the camera shake, if I'm to put a red spring in there, and then hit cycle start again. I've obviously fallen outside of those limits. So now I know that that spring is actually not a good part. Okay. Let's say I want to make the red part a good one and the green part a bad one. Let's go back into the editor. We'll go back to the reference curve here, and I can select a different reference curve. So I'll clear that initial one. Last one we're looking at actually ended around 66 millimeters. So I'll select the last one that we ran and click set as reference curve for that. And you'll see my strategy is still related to the last part that we ran. So you see the window still starts at 66 millimeters. So what we can actually do is change that offset, say from 64 to 65.8. We'll click the window, 64 to 65.8. And now we've readjusted that window. So if I go back to my cycle or my programming here, run another cycle. Now that part is good and it's scaled for the red spring. And just to reiterate that example, we'll swap it out for the green spring and run the cycle once more, and we should fail the part. Okay, so we'll put the red one back in just so we don't have to switch the reference again. We'll run another cycle where it passes. Just make sure. And then what we'll do is it's kind of the last part of the programming. One thing that we like to pull out of our processes when we get to more advanced stuff is pull out things like peak force, final position, items like that we can also pass or fail on. So we can we use the monitor to see if there is a distinct difference between parts from part to part. So if I'm running, say, 1,000 parts a day or something like that, and they're all going through these limits, and then I have one that breaks outside of that limit, that allows me to catch those anomalies like that. What happens if I pass those limits, but I don't reach the force that I need to hit in order to make a good part, or I don't reach the final position that the part print calls out? We need to pull some gauging data to be able to pass or fail based off of that as well. So let's go back into the editor real quick. So I'm going to leave the monitoring for a second and go back over to these steps. What we want to do at the end of the program here is add in a gauging value. So basically, I need to create a piece of data that I can pull from reliably and then put upper and lower limits around it, and then I'll create a label for it. So if I delete that real quick, I'm going to go over to the monitor. Let's just say I want to find out what my final position is for the overall, and I want to find out what the force is when it exits this window. So in my toolbox, I'm going to open this up. So in order to find the overall final position, I actually need to select acquire here, because I don't want to find my final position within this window. I want to find it in the acquire, which is the whole curve. So I'm going to click Toolbox, and I'm going to click maximum Y. Where's that? Maximum X. So if I close that, you'll see now there is an arrow there, which is pointing to wherever that maximum X ends up, and that is outside of the window. And then I want to find out what my force is inside the window. So I'll select the window here. We'll open up the toolbox and we'll select maximum Y. So that's added into the window, and you'll see that there's a maximum Y added in here. So we'll go over to steps again. We'll go to the main tab. We'll select evaluation and then gauging here. So we're actually looking at the function results of that force over position. We're going to look at the max X and the max X value. Let's just put 70 in there, or should we say, let's say 66 and, doing that. 66, and we'll put the upper limit at 70 right now. And we'll call this our max position. Enable storage, yes. And we'll add another one in called force over position, maximum Y, and we will call this the Y value. I don't know what this will be, so we'll just set a high upper limit. And we'll call this window max force. And we'll enable that storage. So we'll save that to the controller. So basically what you'll see here, if I crossed all my T's and dotted my I's, is I'm going to run another cycle, and you should see a line come up that has the max position and the window max force in there. Gives me my date and time stamp, a serial number if it needs to be added, and then you see the gauging data here. So basically on this last one, you also see it on the graph, maximum Y1 is equal to 391.353, which correlates to this window max force here. And the final position or maximum position is 66.30. I can also come in here and I can change the format of these decimal places. Format, if I wanted to say 3 decimal places here on the position, I can do that as well. Let's take a look, see here. Can you overlay the curves of both springs? You can in the we have another software that will allow you to pull this data out, which is called the data utility, and you can do multiple overlays in the system. You can't do that here, but this allows you to kind of scroll through different views. But the data utility that comes free with this software, with any of our presses, allows you to kind of pull more advanced queries. So you can pull a query on based off of serial numbers, date and time stamps, things like that, to look at all those curves together. Can you define a reference position to decelerate the press just before reaching the final load? That question is from Coco. Yes, you can actually. You can come into the move to signal here. There is a step in here called use initial force. It's actually underneath the advanced tab in that move to signal, where you have an initial force. So if I select use initial force and then put in a value, we actually won't start decelerating that press until you reach that force. Trying to explain this a little bit better. So we have, there's two things that go with that, the deceleration limit here, and then whatever your target value is. So if I was to, say, draw a graph of the force versus the velocity, make sure you guys can see that. Let me switch the camera here. So if we have, let's say we have a force curve that looks like this. My velocity for most move to signal steps is going to start out, while there's no force down here, it's going to start out high. And then once we start to see force, we're actually going to use that position to start decelerating the press. And that's going to be actually proportionate to the force increase. So as the force goes up, we're actually going to start slowing the press down. And what that, the deceleration limit percentage in there is the speed limit at which we stop. So for what we currently have, it's set to 5%. So if this is 5% on the velocity, we are never going to go below 5% of whatever that initial rated speed was. You can mess with that. So you can either make it go lower, you can make it go higher to mess with how that curve looks. That use initial force, which I showed you, allows you to change the position of where this starts. So if you want a more aggressive deceleration, say for cycle time reasons or things like that, you could put that deceleration out here. So now we're going to continue to maintain speed until here and then ramp down to that 5%. So you're actually getting a much more aggressive curve there on the velocity, but you may overshoot your target at that point, depending on how fast or how quickly you reach your shoulder that you're pressing to, or whatever feature you're pressing to. So hopefully that that answers that question. Let's see. I know we're getting a little bit over time here. Just wanted to, let's go ahead and go into the Q&A. So just to kind of wrap up the move to signal. So we've set up a rapid position. We've set up a monitor trigger to start our monitoring. We've set up the move to signal, which is moving to a target force value. And then we're ending that data acquisition or that monitor, and then moving back up to 0. And then we have a couple gauging steps here, which allow us to set pass or fail limits for final positions, peak forces, window forces, many other things. Certainly we have As you've probably seen in this demo, we have a lot of customization capabilities for the programming. I would challenge any of you, if you don't think that we might have the capability, to just give us a call, because I don't think there's any sort of application out there in the manufacturing world that we can't handle in just this software. So what we'll do is we'll go to the Q&A portion, which is this button. So if you guys want to just throw some questions in to the Q&A, and I can answer. I know we're a little over time. Sorry if you got other meetings to get to. It looks like 80 some of you are still sticking with me. So I don't have anything right after this, so I'll stick around as long as you guys are answering questions. My friend Danny from Canada, can you set up a program that has early detection of a bad part to limit scrap? For example, if the wrong part is in the nest, and it could be detected early and prevent that part from being scrapped. We do have that capability. Thanks for the question, Danny. The easiest way to do that is with that's a little bit more advanced in terms of the programming capabilities, but essentially what we can do is actually detect a particular rate of change that allows us to see a force spike. That way, if we see that force spike before we're actually looking for it in the curve, we can actually stop the press at that point and say, okay, we're not going to move anymore, flag the operator, flag an engineer, those types of things. Yeah, essentially, yes. That is the short answer to your question, Danny. But I bet you probably already knew that. Thanks for asking that. Let's see. Jorge asked, what is the maximum recommended speed in order to get good control for the force target value? Is there any risk of an overshoot? That's all application dependent. Thank you for the question, by the way, and many of your questions today. It's all application dependent. So if you're going to a hard stop, obviously you're overshooting it is going to do nothing but really make the force spike at the end of your cycle. If you are looking for particular cycle times, yeah, you probably want to mess around with that. Most of our move to signal steps, I've seen 10 millimeters per second. I've seen 2 millimeters per second. On some of our high-speed application, I've seen 80 to 100 millimeters per second. It's really all just application dependent. If your tooling can take the extra load and you're really pressing for cycle time, it's just a matter of experimenting to see what that machine's capable of and what that press is capable of. Obviously, you don't want to overload the press or anything like that, because if you, even though we do have an overload in our system, the overload triggers once it sees that particular force. So if you're moving at 100 millimeters per second into hard stop tooling, we are going to react to the overload a lot later than you really need it to, because that's basically just a trigger, and we still have to decelerate the press at that point. So you can still hurt the press even though you have overload set up in your system. So that's just something to be cautious of when you're working with higher speed press applications. But certainly, if you have any questions about that, we have lots of guys here at our application engineering group that can help you with those particular answers that are suited for your particular machine. I'm sorry, the table's a little wobbly, so you're getting a little camera shake there. Can you set a hold time? You certainly can. So if I wanted to say hold for a second after, make sure that you guys can see what I'm working with. If you wanted to hold, say, for a second after this move to signal, you could come in here, insert a step, and then underneath our program flow, which has things like jump locations, I can jump on values, I can jump on field bus inputs, I can jump on discrete inputs. I can throw in a delay. It has a millisecond timer on there. throw in a 1 millisecond delay here, save the controller, and now if I go to my press, cycle start, we'll go to that force, hold for a second, and then back off. Good question. Thanks. Let's see. Can you use the new software with the older Motion Pro controllers? Good question. It depends on which controllers you're talking about. We do have some similarities between the two systems. There is some hardware upgrades that have to happen in order to use the newer controller, and it's definitely a different system. Most of the press mechanics, the motors and things like that can be reused. But if you're interested in that, we'd have to look at your specific system. So if you want to reach out to our engineering group, now that we have that's Mr. Pete from, okay. What we can actually do is we'll send you an email after this webinar and see if you have a specific unit that you want to upgrade for that, because it will take a little bit of planning to figure out which parts are needed to be replaced. Michael asks, do rotational axes have the same control as the standard axis does? Yes, we actually use the same software for both the rotational and press products, so the linear travel and the rotational. We even have a remap for those that you don't know. We have our rotational press, which actually has two axes in the same system. We can control all of that through the software, and it's basically instead of like millimeters per second or millimeters traveled, it's degrees. It's degrees per second, or we could even do RPM. Mike asks, is there a log of the changes made to either the limits or the graph limits? On this software, since it is newer, that particular feature hasn't been implemented yet, Mike, but on the Motion Pro side, definitely is in there. It will actually tell you the date and time, whoever logged in to make that change, and what the change was and what it was changed from. So say you have, say, like a third shift guy that comes in and changes a bunch of stuff, and then first shift, isn't running production because of it. You can actually go back and revert all those changes and make sure that the machine is back to where it was before that shift started. If that is something that you're interested in, we do have password protected profiles. That would be something that we could definitely get set up for you if you have one of our systems on the floor already, or we can show you in a separate demo on how that works. You're welcome, Jorge. Thanks for asking those questions. Sean asked another software question. What about the even older EMAC controllers? That's a great question as well. Really, that's application dependent too, but there's less similarities between, say, the EMAC and the Ultra Pro versus the Motion Pro and the Ultra Pro. So that would probably be a little bit more, what do you say, like cost intensive to go from, say, the EMAC to the Ultra Pro. But if it's like the later EMACs that use some of the same drives that the Ultra Pro or the Motion Pro did, we may be able to work around some of those older issues. But if you are having say questions about whether or not you can upgrade, or you have a line that needs to run for a certain amount of time longer, we can definitely help with those. So you could either call us or send us an email, and we'll answer those questions in a very specific manner to your application. With this new software, can we go inside the programs while the Promess is running? Carlos, great question. Yes. At the beginning, I talked a little bit about this, but all of the changes that you saw me make in the software while while I was making those changes, are offline changes. And then once the press stops running production or stops its current cycle, you can save those settings down to the controller. So all of the additions or subtractions in that program that I made were all offline, not affecting the controller at all. So you can be running full production while you are making those changes, and that will allow you to make those changes on the fly. That was definitely a pain point in the Motion Pro software that we fixed for everyone that told us about it. So thanks for that feedback. If transitioning from the NC module to the Ultra Pro, would you say it's fairly straightforward for programmers? Yeah, like I said, Steve, thanks for the question. All of those things are really application dependent, but the programming essentially is the same. The ease of use and the quality of the programming is basically, I mean, you're just adding steps, you're putting in move to signals, you're deciding which sensors to use as your closed loop feedback. All of those are factors, but realistically, any of our systems from NC Module, EMAC, Motion Pro, Ultra Pro, all of those systems have a lot of similarities. So they should all be able to handle any application that that you're currently dealing with. Now, the Ultra Pro just adds another level of that. The EMAC had it kind of back in the day too, but the Ultra Pro allows you to add multiple axes. So right now you could have up to 8 press axes on a single Ultra Pro controller, which really allows for some unique and interesting test applications. You know, if you're working with a flex cell with more than just a press axis, maybe you have some XY axes that you need to move around, or some tooling axes like a dial table or something like that. We can all control that in one interface without even having to use a PLC, depending on the application and how complex it is. Yeah, no problems, Sean. I know you guys have some EMACs up at that facility. So yeah, I know the engineer specifically that was working with you guys. I can always have them reach out and see if you guys want to set up another demo offline. Because we could definitely kind of walk you through the steps of getting those systems, especially if you're going to run them for quite a while longer. You might want to upgrade. So unless there's any other questions, that's basically all we had today. I'm sorry I ran a little bit long. I can be a little bit wordy when it comes to describing the software and our product that we have for you guys, but we'll go ahead and end it here. If you do have any questions, feel free to reach out. You can either put in a web submission at promessinc.com. You can call us at 810-229-9334 to talk with an application engineer or a salesperson directly, or send us an email. You can go, I think it's promess@promessinc.com. That'll get directly to someone on the sales or someone on the applications team. Ricardo, yes, there will be other webinars. We're doing quite a bit of webinars right now, generally around 1 per month right now. So if you guys have any ideas for future webinars, we'd like to do more of these programming style. We have lots of different types of programming that we can show you guys. Move to position, move to a rate of change, move to an external probe or an external load cell. Those are all really simple applications for us in terms of our programming. So if there's any way that we can show that to you guys, if you guys are interested in that, any feedback that you send into Promess kind of drives where our webinars go and what we talk about for any particular type of application or webinar that we're going to be talking about. So I do appreciate you all coming out. Hey, Brian, it's been a while since I've been in the Southeast. Good to see you. Thank you for coming out. And if you guys do have any extra questions after the webinar, feel free to send them in, and have a good day. Thanks for stopping by.